Hi, geometry students. It's Jessica Dresch again. I am one of the geometry teachers here at Alton High School, and these guided notes are for lesson 2. We're going to be simplifying radical expressions and then using them to solve some equations and just generic solving equations. This should be in your workbook. It's lesson 2, and if you look down at the bottom, it should be page 3. So that purple workbook that was given to your registration, or should have been, go to page, did I say 2? Page 3 for lesson 2. So we're talking about radicals. So this first problem that's on there is the square root of 144. Now remember, square root means what times itself is 144. So the square root of 144 is the number 12, because this basically means under the radical, 12 times 12 is 144. And when you have pairs, it's a perfect square, and the answer is 12. Now, this one is, depending on how much you still have memorized after 5 months of not doing math, might be a little more obvious, but there are problems that don't turn out to be nice whole numbers like this. And there are problems that just look a little worse. So number 2 is one of those. It looks awful because there's this fraction, but the nice thing about radicals, or at least in my opinion nice, is you can break them apart. So you could put a square root over the top and a square root over the denominator. So the square root of 25 is 5. 5 times 5 is 25. The square root of 4 is 2. 2 times 2 is 4. So once I've square rooted, the radical is gone and my answer is just 5 over 2. I'm going to leave it like this in geometry class unless we specifically tell you to give us a decimal. We don't want a decimal. So you see this big bold instruction here, no decimals. We don't want you to tell us 2.5 even though it's equivalent, even though it's about the same. Number 3 is really similar. The only difference is this 4 out front. So if you think back to your algebra class, if you had a 4x, there's no symbol, there's no plus, minus, multiply, divide in between there. And when you don't see a symbol, you assume that it's multiplication. So this is 4 times whatever the square root of 49 over 16 is. So I'm going to keep the 4 times out front, but I'm going to break apart the fraction. So I'll have the square root of 49 in my numerator, the square root of 16 in my denominator. And then I'm going to go ahead and square root. So again, I'm just ignoring this 4 times even though it's still there. The square root of 49 is the number 7. The square root of 16 is the number 4. So that fraction turns into just a regular 7 over 4. And then here's a couple issues. You have to remember how to multiply fractions for this problem. So back in your middle school days, I'm hoping at least, they told you to make whole numbers into a fraction and then multiply straight across. By that I mean let's multiply our numerators. 4 times 7 is 28. We're going to multiply our denominators. 1 times 4 is 4. And then I'm going to simplify my fraction here. 28, excuse me, divided by 4 is 7. So the final answer is 7. At this stage, I could have simplified that because if you remember, if you have the same number on top or bottom, you can simplify those because they're equivalent to 1. If you forgot about that, clearly I still got the same answer, but just a bit of a reminder. So fractions sometimes happen in radicals, but you also get numbers like this problem here. There is no one whole number that multiplies by itself to turn into 18. You're never going to find that. So instead, we just need to find some pairs that do make up an 18. There are different ways that teachers can teach this, but I always start having my students just ask, well, in general, what multiplies to be 18? Excuse me. I'm going to use 2 times 9. You'll notice that 2 cannot be broken down into anything else except 2 and 1. So I'm just going to circle it. But 9 can be made up of a 3 times a 3. So I'm going to break that apart. 3 can't be broken down into anything but 3 and 1, so I'm going to circle those. So what I actually have, instead of the square root of 18, I have the square root of 2 times 3 times 3. And just like earlier, where I said pairs make perfect squares, if you see the same number twice, that means you can take the square root of that, because really, 3 times 3 is 9. And if this had just been the square root of 9, you would say, oh, I know the square root of 9. That's the number 3. So pairs make perfect squares. So that 3 times a 3 under the radical is going to turn into, that 3 times the 3 under the radical just turns into a regular 3. So no square root at all, I have a regular 3. But there are not a pair of 2's, meaning I don't have a perfect square. This 2 is still going to exist inside my radical. That's the simplified answer, 3 square root 2. And if you would type that into a lot of calculators, not all of them, but a lot of them, it would tell you 4.2426406, and it's a horrible decimal that we don't want. This is the simplified answer, not a rounded answer. So this is the process of simplifying radicals. We're going to do the same process with number 5. What I want to point out, number 5 is a lot like number 3, where there's this number out front, this coefficient. So it's still going to exist out there, and it's still multiplication. I'm just going to ignore it for a little bit. So I'm going to ask myself, what are some things that multiply to be 48? There are lots of pairs. I'm going to choose 6 times 8. And then I'm going to ask myself, well, can I break that down further? And I can. 6 is 2 times 3. I cannot break apart a 2. I cannot break apart a 3. 8 can be broken up into 4 times 2. 4 can be broken up into 2 times 2. And I'm just going to keep going until all my numbers are simplified, or broken apart as possible. So I'm ignoring the 4 and the 8 because I've already broken them down. So now I'm going to rewrite this original one. There's the coefficient of 10 that still exists. It's still being multiplied by something under the radical, but now under the radical are all of these numbers that I have circled. So there are 1, 2, 3, 4 2's, and then a 3. Pairs make perfect squares. So I see a pair of 2's here. Well, 2 times 2 is 4, and I know the square root of 4. If I had asked you yesterday, what's the square root of 4, most of you would remember that the answer is 2, which means outside a radical, this is a 2. But don't forget, outside a radical is still this 10. A common mistake is to forget about that coefficient. It's still out there. And then also, pairs make perfect squares. When I have a pair of 2's, the square root of 4 is a regular 2. If you don't have a pair of numbers inside the radical, it stays inside the radical. And then I can just combine all the coefficients. 2 times 10 is 20, times 2 is 40. So my coefficient is now a 40. There is a square root 3 at the end. Let's do one more, and then I'm going to pause the video and set up another YouTube video so it's not just like a 50-minute long video. -6 square root 60. So we still have multiplication. Doesn't matter that that's a negative number. Negative numbers exist. I'm going to break apart the 60 because I don't know anything that multiplies to be 60. Any number times itself. I do know that 6 times 10 is 60. So that's what I'm going to do here. But I want to break it as far as possible, and 6 is not broken down. The prime numbers that make up 6 are 2 and 3. 10 can be broken into a 2 and a 5. 2 is broken down as far as possible. 5 is as well. So I'm going to rewrite it. I'm going to not forget the number out front, which was -6, and it's being multiplied by this new radical. So instead of a 60, I'm going to rearrange them. So I'm going to put the 2 smallest numbers first, then the next smallest, then the next smallest. So I just rewrote these numbers. Pairs make perfect squares. So I have a perfect square here. 2 times 2 is 4. The square root of 4 is 2. So yes, there's a -6 outside the radical. Joining that -6 is a 2. So to come out of the radical, you need pairs. There's still a 3 and a 5 though, because there's not 2 of those 3's or 2 of those 5's. And that's all I can do. Just take out that pair of 2's. So I'm going to multiply everybody back together. -6 times 2 is -12. And inside the radical, 3 times 5 is 15. That is as simplified as -6 root 60 can get. So like I said, we'll continue with some more problems on the next guided notes video that will be linked. And we'll finish the next 6 problems on that.